Welcome to Architecting Hybrid Multi-Cloud Cloud Architectures. This is BRK DCN 2916. Thank you for attending. We have 90 minutes together. I promised I'm going to try to get you out early. I don't want to be between you and like pre-gaming before the Killers concert tonight. With that, my name's David Jansen. I'm a distinguished engineer, as you can tell by my accent. I'm from Michigan. I'm going to try to keep this fun. I present at Cisco Lab globally, and I've been doing it for quite a while. So thank you for coming. There's a couple things that I do from a day job. I'm a field resource. I work with customers day in and day out. And what you're about to see is I packed as much information as I could into one, the slide density, and then two, the time, 90 minutes that they allowed me to do. I'm going to walk through a journey here on how, when I show up to a customer, what are the things that I'm talking about from a multi-architecture point of view. So we're going to touch upon, what's happening on premise, what's happening in the cloud, the users, applications, and tying policy together. So it's going to be from a field point of view. I also work on technology strategy. So I work a lot with the BU, the engineering teams, capturing market transitions and what's happening. As you can see from the announcements this week, what's been taking up a lot of my time is this thing called AI. So I've been doing a lot of innovation and things around AI. As you can tell, that picture is a few years old. I've lost a lot of hair since the picture. I've been at Cisco for a long time, about half my life. I published and authored 4 Cisco Press books. The most recent one was VXLAN EVPN. We keep saying we're going to do a second edition, and it hasn't happened yet. It's just a matter of prioritization and time. I enjoy, I have a wife, 3 kids. We enjoy the outdoors. I try to stay active, do a lot of running and lifting, and just trying to keep up with the 3 kids. If you have any questions, please stop me. I'll take any questions. I'm available after, and I've been at the MTE all week. I know we're coming up to the end of the show, but the WebEx space is open for questions. I don't know how long. I think it stays open until the end of next week. I'm moderating that space until they close it down. I posted the slides into the WebEx room because the first question I usually get is, do you have the slides? I posted them in the WebEx room. So if you have the WebEx app or the Cisco Live app, they should be posted in both of those. So I put it into the WebEx space just so you have access to it, and it's electronic so you can take notes on it. With that, here's the agenda. I'm going to roll through, why are we even having this conversation? What's the outcomes that our customers are after based upon the challenges and issues that they're talking about? What are key capabilities? And the reasons why I know this is a data center track, but in working with customers, how many customers here in the room are after an end-to-end segmentation outcome or journey from an outcome perspective? Hopefully we get a lot of hands. I got a few. Okay, at the end of this, hopefully we'll have more. That becomes a common theme. And with that, how do we sort of get there? What are the key capabilities? What are the use cases? Because you can't make a policy decision by just looking at the data center side or just the user device and thing. And the reasons why this is important, IoT has been exploding, and it continues to explode and grow. And the reasons why I say that, customers are investing in the OT, IoT side of the house more than the traditional IT side of the house. So how do you allow for non-intelligent devices to come onto the network, and how do you adhere policy to where you don't get devices compromised? That needs to be part of the overall architecture, and I'm going to go ahead and cover that in quite a bit of detail. I'm going to close it all off with common policy. And then you can't do this without visibility, so I have a bunch of things on visibility. This is an iterative process. It builds upon some of the things that you saw announced this week for that, and I'll wrap it up and close it out. So this is the abstract that I wrote. Hopefully everybody read it. I can't assume that you read it, but I'm going to go ahead, like I said, talk about how do we connect users, devices, and things and applications, and segment that, with different enclaves that are happening, network operations, security operations, cloud ops. There's all these different personas that we need to actually align to. With that, we're going to have, back to the non-intelligent devices. So you have things that you can't put agents or certificates or supplicants on. So you need to have some sort of network type segmentation. Then there's the intelligent side of the house to where I can do, SAML and OAuth from an over-the-top to a cloud security stack to achieve a zero trust. I'm going to cover both of those capabilities to align to the zero trust framework. Taxonomy, I try to keep taxonomy consistent throughout the presentation. These are just definitions. We can have a discussion about them, but when I'm building things out and talking to customers, hybrid cloud is a private data center plus cloud. Then you get into, multi-cloud is 2 or more cloud service providers plus hybrid cloud. How many of you are in more than one cloud provider today? So that's usually what I see. About 98% of the room raise their hands, and this is the things that we need to go ahead and build for. Here's a terminology matrix. I put this together for the attendees. So there are the same capabilities exist, but they're called different things. So you can go ahead and click their hyperlink. You can go ahead and click through it into the PDF that's attached to you, and you can go ahead and get the definitions, the configurations, what these things are across the different cloud providers. So with that, what are the challenges that we're trying to solve for today? These are primarily the 3 pillars. If you look at the industry and what's happened, there have been certain events that have happened on the application side of the house to where things have failed. I'm not going to mention the things, and this is recorded, but there are things that have happened. And based upon those events, customers are treating this like ransomware. Why is that important? I need to have the applications segmented in a certain manner to prevent lateral movement in the damage control that happens with these recent events that are happening out in the industry. For network connectivity, I have not had a network connectivity conversation with a customer that has not been a security-led conversation. You can't have the networking conversation only. Typically, they're security-led. And you hear Cisco, I think you'll hear it from a lot of our executives this week, something they coined the term secure networking. What I'm going to demonstrate here today, and hopefully the audience would agree, is I'm going to talk about capabilities in use cases and put context and a little bit of definition behind what secure networking is, and to address the different personas in the customer environments from an operational tooling perspective as well. So visibility, security, networking, typically in the enterprise, those yield different, administrative domains, different operation centers, different planning centers, different design centers, sometimes different tooling centers, sometimes the same tooling, to give you different personas to achieve the same outcome. And how do you tie this into cloud? So you have all these different things. How do you have a common thing across all these different cloud providers? So when everybody raised their hand, they're a multi-cloud. How do we abstract that and apply the connectivity, the security, and the visibility to all of those pieces? This is not a shot. This is just how things are. So in cloud-native routing, if I want to reach a destination, and I say that to that destination, I have the intent to reach this prefix. In this prefix, I want to use all possible paths for that prefix. So I want to yield the outcome of equal cost multipath routing. Today, this is sort of what happens. So I have the intent. I'm going to program that. That's my destination I want to reach to. So I have a next hop. And what's programmed is I yield a single next hop. So it's hard to derive ECMP in this topology. So for inter-region in the inter-region connectivity, you have different options. I listed here a set of options and capabilities because customers come to me and say, hey, how do I connect, between CSPs, what are the connectivity options? And the reasons why, we work with customers that are global, right? So depending on the region, depending on the cloud service provider that you're in, and we'll get into the middle mile optimizations and things along those lines, you have different options and different price points for that. So with that, when we walk through this, and we're going to do this a little bit today, what are the different design options, and what can I go ahead and take in and take out depending how costs fluctuate and change over a period of time? So if you build out the architecture, you can plumb in some of the different capabilities that sort of sit here in the middle. And I'm going to go through all of these. There are some SD-WAN sessions that will go into 5 and 6 in much more detail. I just don't have the time to go through it. So with that, when we look at multi-cloud connectivity, how many of you are in colo and do like direct connects between like colos and the CSP providers? Awesome. So hey, the segmentation stuff started off a little bit rough. So we're in multiple clouds, and now we have colo connectivity. So we're going to build on top of that. Not all applications are created equal. And what do I mean by that? Certain applications have to have different types of characteristics from a network perspective. It could be bandwidth, it could be jitter, it could be latency, it can be a combination of all three. So in the colo model, I can do differentiated services. However, the reasons why we do this, I need to have intelligence into the network and have the option to what type of connect, back to the previous slide, what connectivity, so if I want to go from AWS West to East, what are my connectivity options? What are my paths? How do I yield ECMP? What happens when things fail? So if I want to go between VPC1 in this region to VPC3 in this region, what path do I take? I have what? I have an SD-WAN option. These are options. I'm not saying you have all these deployed, but these are all paths that you have from a transport connectivity perspective. I have a cloud backbone, so I can leverage the CSP, the cloud service provider's backbone. I also have the colo connected into the direct connects everybody raised their hand on for express routes and direct connects for that. So which path are these going to take? If I need differentiated services, this is where colo comes in, because most customers have a backbone, whether it's private or through Equinix with their backbone, they have a backbone and they have control over the traffic, the management, the steering, and the topology to give it a differentiated service to where not all application is put across the CSP backbone. The reasons why the stars are there, these are all the different administrative touch points that one has to do to get all of this stuff stood up. So you create all of this stuff, transit gateways, transit VPCs, spoke VPCs, workloads. You attach CIDR blocks to them. Those are all manual steps at a high level. What we're going to do is we're going to automate and reduce all of these touch points and have a solution to architect this end to end. This is showing across the same CSP. What happens if you want to go between CSP environments? So you see the Azure. The animation's busted. I apologize for that. It typically is not going to go across the cloud backbone, but you have an SD-WAN path, and you have a customer backbone. So what are we going to explore? What happens when there's a failure? How are we going to achieve equal cost multipath routing, and what about visibility? So let's go ahead and take a closer look. Any questions, comments, and/or feedback? Good so far? Thank you. So, secure networking. This is a slide that I created, obviously, but I've used this with customers. And this talks about, on the left-hand side, users, devices, and things. So I used to be able, intelligent, non-intelligent devices, and then applications. The reasons why this is important: users, devices, and things, applications, and data are everywhere, right? So we're going to talk about the security perimeter next. But if you look at the stack, we're going to go through how do we do the infrastructure for connecting these different pieces. How do we get to zero trust network access? So back to the network, zero trust network access, the application, zero trust, like the over the top, like the cloud security stacks, to the different destinations to provide the segmentation and capabilities. I do have a little bit on AI security. And the reasons why I do this, I try to categorize, this may be a bad categorization. I lump things into 3 buckets. Legacy applications, maybe a bad term, but applications that have been there in the enterprise space, they typically go and they never go away, and the people that built them are typically no longer there, and they're all L2, and they have all these special characteristics, right? So that's what I categorize as like legacy applications. Then we pivoted to cloud native, and now we have these things called AI applications. So we have a language model that's part of the application now, which is different than traditional two that I mentioned, like legacy and cloud native. So how do we address the AI applications coming into this as well, whether they're in the cloud or on-prem or a SaaS-based service? Again, I try to explain all of my acronyms. Sometimes I fail, so if I say something, please stop me. I will make sure that I repeat it. This is another eye chart for more, taxonomy and, buzzword bingo as it relates to acronyms. So here's the overall topology we're going to spend a lot of time on, to where I have remote users connecting into a VPN service, and the trend here has been what? Don't want to relive COVID anymore. I'm tired of hearing about it. But what happened? Customers moved from on-premise VPN, like terminating in data centers, to cloud security stack. So remote users were terminated into there. They would go to different destinations, whether it's a private app in a data center or a private app in a cloud or a SaaS. Then you also have sites, people working from home, people working from a coffee shop, working from a branch office. What do those capabilities look like? And then how do we handle security? So within the SD-WAN edges, we have capabilities of putting a security stack at the edge. Different customers, and I'm going to talk about how we're managing that because it's different. One of the big problems we had is didn't have very good tools to manage the security policy like in a Catalyst C-Edge SD-WAN box. We fixed that problem, so now you can take, whether your capabilities are a layer 3, layer 4 firewall for stateful, we can achieve that. If you need identity-based services, so integrating with like Azure AD, we can do that. We can also do NGFW, next-gen firewall, for example, on FTD. We also have the capability of putting an NGFW in the colo facility. Why is that important? So the question that I asked, how many of you are in a colo? There's typically a security stack sitting there, right? And that security stack could be physical or virtual. We can automate the instantiation of a virtual environment through what we're about to talk about here. And the reasons why this is important for a third reason is typically the security stack handles it on a per destination basis. So in the question that I asked about multi-cloud, you're in 3 different cloud providers. You have a security stack, whether it's physical or virtual or a combination of both, based upon the destination, that security policy and security stack could be different across the cloud providers, and it could be different within the cloud provider based upon the application that you're serving up there as well. So we can accommodate all those different use cases. Middle mile. Middle mile is, by definition, how I define it, is leveraging more internet transport to get to like the first mile, like the home, the office, et cetera. The last miles between the middle and the cloud provider. But the idea is get the traffic to the security stack, the middle mile optimization, colo, as fast as possible, apply the security services and get it off to the destination. You see the SASE security stack sitting in the middle. By definition, those cloud security stacks are middle mile optimizations as well. Does that make sense? Question? So again, why is this important? So you have this is more of a logical drawing. So this is saying, hey, if I have that C-Edge or that NGFW in the middle, I can do identity-based to the directory, like Azure AD, SGT-based. How many customers in the room or partners are doing security group tags, SGTs? Awesome. So I'm getting different, I love this, I'm getting different answers to the questions that I'm asking. This is metadata on how we're abstracting and automating security segmentations and decoupling it from the actual network to where I have firewalls, SD-WAN devices, fabrics in the data center. I'm going to get there in a second, to where I have things coming from the left, users, devices, and things, to applications on the right-hand side. This is what we're doing. I'm going to expand upon this to where you have a matrix here, and you can see, depending on the source group and the destination group, you can permit and deny traffic from a policy perspective. I'm going to build upon this because where we're at today, it's very compelling to simplify this for the entire stack across your organization. All right. This is a little bit of SD-WAN. This is about connecting transport. So whether you're connecting a branch, a user, like the VPN user, or sites, and data centers are included in sites, like we still have, even though everybody's cloud first, we still have these things called data centers, right? We have to connect those things up. Because what I've also seen, and I'd love to get the audience's feedback, there's been a lot of repatriation of workloads, meaning customers started off into the cloud. It was a cool thing to do, right? Whether it's a business case or not. And what I'm seeing is with AI sort of driving a lot of this, they're moving from cloud in a selective basis and bringing it back on-prem, meaning we're building out new things and new infrastructure on-prem, whether it's a colo or a traditional data center with an actual street address. So, whoops, sorry about that. So, pivoting a little quick. Wait a minute. Sorry about that. The clicker had a mind of its own. So here we have Catalyst SD-WAN Manager. This is the controller, the abstraction point that sits up top and automates and orchestrates. So back to those stars up top, this is what we're going to do to simplify the creation of those elements in each of the cloud providers. So as you can see, we have a various amount of support for the cloud and SaaS application optimization. Again, backed from an SD-WAN perspective as well. Not all applications are created equal, right? Collaboration tools in Office 365, which is based on experience, typically they have you bypass a cloud security stack for that, right? So you need to have the capabilities to understand what that traffic is, to not send it up to the cloud security stack. You have intelligence at the edge to send it out like a local egress, as one example for that. To cover automated network security segmentation, and if I need to put 4 through 7 services like a load balancer or a firewall in a data center or in a cloud provider, I can do that as well. So I try to apply context to things, meaning that when you look at this from a physical hardware perspective, over the years, showing my age probably, so we had supervisor modules with like centralized control plane. Then we added distributed forwarding cards to like I/O modules, right? So you can do learning on the cards. The cloud model is sort of the same way. So I had that centralized control plane, the actual Catalyst SD-WAN manager sitting up top, and I'm pushing the data plane forwarding to each of them. So I had the same hierarchy and the same scale by leveraging the CSPs as well from a software perspective. So personas. How many members in the audience are part of the NetOps or NetCloudOps, like operations planning team? Nobody. Cloud operations. A bigger percentage, and then like NetSecOps or security. I classify. I mean, these sort of vary. How many are all in one team? Awesome. So, depending on the org structure and where you sit, like commercial, enterprise, et cetera, sometimes they're consolidated into a single role. The whole point of this is, what I'm about to show here is we can align to, if they're all merged into a single thing, that's a little bit easier, right? But when you have these different groups in different clouds, how do we go to these different personas and allow them to do the things that they need to do, and allow the other team to see what they did. And this is where we have the workflow, to where in the controller, you will enter your accounts. So again, the different CSPs call them different things. In AWS, you have accounts, subscriptions in Azure, et cetera. So you would enter those into the cloud provider. Then what we do is we'll discover and understand the tagging and the inventory for that. Why is that important? Brownfield, to me, is the #1 use case for everything that we do. I very rarely get a greenfield anything. So understanding what's there, and customers, are in cloud before SD-WAN even became like a thing, right? So now I can discover and understand the workloads where the actual applications sit and the things that the cloud operators define from a tagging perspective. These are cloud-native constructs that happen in the cloud providers. Then you have the ability to leverage the cloud-native routing engines, like in Amazon's case, the Transit Gateway, or you have the option to deploy a Catalyst 8KV virtual, or a combination of both. And I'm going to get into those use cases. When would you do one versus the other, and when do you do both, kind of thing. And then we do the attachments. So there's something called like attachment circuits. So you need to connect like the VPCs to the TGWs and the TGWs to the Cat 8KV. We automate that connectivity for you as well. What do we also do? Let's say you stood this up. You stood it up, you discovered the workloads, you deployed the transit gateways, you deployed the Cat 8KV, whatever, and then someone comes along and adds a new VPC or adds to an existing VPC and added more workloads. We'll rediscover that, and we'll add that to the inventory and to the networking topology automatically. So again, back to reducing those points of administration from the 4th or 5th slide that we went through. I'm going to roll through this a little fast, or faster. I cover 3 use cases with Azure, AWS. Google is hidden, but if you look, you're going to see similarities. Again, the terminology changes. Architecturally, we're doing the exact same thing, to where I have 3 use cases per cloud provider. I'm going to talk about region to region, site to site, and the third one is site to cloud, so cloud on-ramp, right? I'm going to cover each one of them and talk about the different automation pieces that we do, and this sort of builds upon this. So if I have region to region, so again, if I look at the first example that I tried to articulate before, I have a cloud operations account and I have my network operations account, and the clicker's not working all that great, so I apologize. Here, and I want to connect these two together. I'm going to enter the account credentials, and what's it going to do? It's going to do the things that I said it's going to do, create the VPCs, the CIDR blocks, and automate all of those pieces. It's going to lay down the transit gateways. What's it also going to do? It's going to build the routing relationship between the TGW. So I'm going to build an underlay routing of IBGP between them, okay? And then where's the default gateway? From a cloud workload perspective, it's going to be the transit gateway. The reason why this is important, once we insert the Cat 8KV for SD-WAN, you're going to see we need to do some redistribution and things along those lines. Site to site. So this is very common to where customers have a cloud service provider. In this context of this is Amazon, and they have sites across the globe or across the geo that wants to leverage the cloud service provider's backbone and have a site on the left and a site on the right. And as you can see, I live a very boring life, and I spend a lot of time with animations here, to where you have, on-premise region 1 in a different region, whether it's, within a country or a continent or across, to where, bless you, I'm going to go ahead and build this thing out. What's different in this topology? I have SD-WAN at the edge connecting to a transit VPC. What is it laying down here? It's laying down the Cat 8KVs in the transit VPC. Do you see that animation? That's the attachment circuit that's happening between the Cat 8KVs and the TGW. So I'm laying down all of this. So I have SD-WAN tunnels coming in to this transit VPC here. And then what's going to happen? The underlay that I built in the previous example, I'm leveraging that underlay to have that connectivity happen between the sites, and then I have SD-WAN tunnels going from region to region, and that builds out the SD-WAN fabric across the CSP backbones for site-to-site connectivity. Does that make sense?
Can I ask a question?
Absolutely.
So during these TGWs, are you only advertising the keywords?
Yes. So the question.
So everything, all subnets inside the regions and physical sites will be advertised over OMP.
That's correct. So the question is are we advertising the TLOCs? The TLOCs are the locator ID of the SD-WAN edge devices. Are we advertising those? And the answer is yes. And then OMP was the other part of it. OMP is the control plane protocol that does the route reachability and the route advertisement for the SD-WAN fabrics. Thank you. That's a great question. So the last one, or the third one, is site to cloud. So I'm going to do the same thing. I have a site, and I want to have it access the resources. Now, this is typically an and. So you'll have like a site-to-site for specific traffic flows. Then you'll have a site-to-cloud, again, depending on the application and or the destination, whether it's transient or destined to an application. I just couldn't fit it all on a single slide, but you can do, like, you can and this to where you have site-to-site plus, site-to-cloud, and then I'm going to bring the data center into this here in a second, to where I have the remote sites terminating in transit VPC. Did I lose audio? No? Okay. Sorry, I heard a clip. Here, to where the SD-WAN tunnels terminate natively into the transit VPC. And this is where I'm going to need what? Route redistribution. Right? Because I have BGP running on the TGWs. I have, to what you mentioned, I have OMP running, and I need to redistribute, BGP to OMP. Now, you see a note here. I have IPsec, so customers want to push encryption as far into the VPCs as they possibly can. Here I have crypto terminating into the transit VPC, specifically on the TGWs. We can get into the conversations, probably not live here, but maybe offline, to have a conversation. So, mileage and performance varies with IPsec in this environment. So if you have higher performance requirements, we can run GRE on there as well to yield higher throughput and performance. Questions? Good? Next is Azure. It's the exact same thing, except we're sort of swapping out the TGW for a vHub. So we'll instantiate the vHubs. We'll run BGP as an underlay between the vHubs. You're going to achieve the exact same outcome. Again, this is all abstracted and managed through the Catalyst SD-WAN manager. So whether you're using the UI, the user interface, or the APIs, or some other external like Terraform, it's the exact same thing. You're plumbing this all to the controller. He's sort of doing the abstraction between the different cloud providers. So, region or region is the exact same thing. The gateway's on the vHub. I have BGP running as the underlay routing protocol. If I want to do site to site, I'm going to do the exact same thing. I enter subscriptions, and it can be multiple pieces for that to where I'll build out the regions, terminate it into the Catalyst SD-WAN. Whoops, sorry about that. And then you can see you have the exact same outcome from an SD-WAN fabric perspective for that. Yes?
So you have vWAN and vWAN. Are they separate vWAN or part of the single vWAN?
So the question is, you have vWAN and vWAN. Are they separate or part of the same vWAN? I'm sorry?
Because you cannot connect separate vWANs. You can only connect them using either MSE,
yes,
or you can build SD-WAN tunnels between the vWANs.
And that's exactly what we're doing. We're building the SD-WAN tunnels between the vWAN hubs, yes.
So these vWANs, they're separate. So there's like Microsoft, like door starting, they're proposing to use the single vWAN for everything.
That's more of a roadmap piece, correct?
Well, this is crap, I'm sorry. This Microsoft has, it's very, very bad design.
Oh.
It's not scalable.
So I'm being recorded. I can't say that, but there are limitations So back to what I mentioned about, ECMP routing, going back to these cloud native constructs. This reminds me, like back in the early days, like, when routing was like classless and classful and doing all those nerd knobs to get routing to actually work. I feel like we're going back in time a little bit with some of the different implementations that you're referring to. So I agree with your comment, but I tried to answer it a little bit differently for the recording, but I definitely agree with your feedback for that. No, you're 100%. You're all good. You're good. Very good question. Thank you. Yes, sir.
Back to the region.
Yes.
Specifically in Azure, do you have to run VLAN on either side, or can there just be like an Azure firewall that just Microsoft?
It does not have to be. It could be just an Azure firewall, yes. Yep.
So you can use Azure firewall to just use that Microsoft underbelly network.
The underlay.
Yeah.
Yes.
Between the two, and then you can have SD-WAN as a failover?
Yes.
Okay.
Yep. And we could talk a little bit more design from a detail perspective if you like after. You're welcome. Very good questions. And then the last one is site to cloud. So sites connecting directly to applications from a cloud on-ramp for infrastructure as a service. And then, like I said, the Google ones are hidden. Oh, and then you have the BGP sessions between the vWAN hub and then the Cat 8 KV. So you see similarities. I just wanted to call out some of the terminology differences, but at the end of the day, we're laying down and automating all of that and reduce those administrative control points. So to reiterate your comment, a lot of customers have VRFs implemented across the SD-WAN fabric, and they want to take those VRFs and like layer 3 segmentations, virtual routing and forwarding instances, and start there and extend the VRFs into the infrastructure as service providers. This helps from a segmentation perspective and get back a stepping stone into the security side to say, hey, we can add the firewalls to the gentleman's point, but the most basic, like we can have the firewalls do the policy enforcement between the VRFs, or we can have like routers do it, to where blue can talk to blue within a cloud and then across clouds. Bad choice of colors, new template, so it's not my fault. I had different colors here, but I had to align to the pieces here. This darker blue and this lighter green, like the common can talk to the same color, but I can't talk across colors. Back to your point, TGW supports multi-VRF, right? So I can do BGP with VRFs v4, v6. But when I get it, the reasons why I have the Cat 8 KVs here, Azure doesn't support VRFs yet. Everything's got to be mapped into the global, right? So this is sort of the context here. So where I need the Cat 8 KVs to keep that VRF segmentation versus the cloud native gateways for that. This is pretty cool. I just came across this in trying to update and create the content for this session. This takes, how many of you are doing ACI on-prem? So about, I would say, a little more than a quarter of the room. Here's the link to it. What this does, this takes the SD-WAN, so all of the group-based policy, like ACI is the group-based policy model, in multi-tenanted, multi-VRF, and what we do is we have a white paper that outlines all of the best practices and how to deploy and extend from on-premise ACI, leveraging Catalyst SD-WAN, and taking the previous set of slides, but giving you more detail, and very good detail, on the configuration best practices to take the tenants, the VRFs, and all the layer 3 outs. So layer 3 outs is the external connectivity, depending on the different models that you want. So if you're multi-tenanted from a tenant perspective, you can either like do a tenant-based or merge them all like to shared and have everything thing. So there's all these different permutations and use cases depending on, I'm a big believer, if I'm doing segmentation, there's no reason to dump everything back into something common, right? So the idea is I can have layer 3 outs per tenant, the different VRFs into there, and plumb that into the SD-WAN fabric and carry that all the way up to the cloud provider. The other piece here is, I know this is a lot of text. I didn't do a whole lot here. I copied and pasted from the document in the previous thing, in the white paper. The whole point here is the automation still applies. It's APIC, which is the controller for the ACI fabric, and then you have the Catalyst SD-WAN manager, so we're leveraging that to yield the outcome of the automation between the on-premise data center and then the actual cloud. And the last piece here is we can do separate cloud accounts. You can see we can do the tag-based. So back to the discovery of the Catalyst SD-WAN, and then you get visibility into the AWS or Azure dashboard. I'm going to close this session off with common policy. So this is, the VRF extension is the macro segmentation, the layer 3 VRF segmentation. What I'm working with the BE on, the product teams, is to add and overlay common policy onto this. Why is that important? So within ACI, you have endpoint groups, which is like a micro segmentations, or you have ESGs. I forget the actual acronym. Services groups. It's like an SGT, but it's in the ACI fabric, to where we can take those and extend the macro and micro segmentation from on-premise into the cloud. This is available today, to where I can have workloads classified on the on-premise and have them mean something to the up top and map that to the user side. We're having that thing updated, and hopefully it'll be ready by this summer. Middle mile. This is back to the question that I asked for the, like the direct connect, express route connectivity to the cloud provider. So this is a way to automate, instantiate the SD-WAN edges in the middle mile optimization. You can see Megaport and Equinix. As you can see here, you have the direct connects. This is all automated via their portals, right? It'll spin up the virtual instances. You can add firewalls to this, like I said about the NGFWs. Typically what I see here, and I love to validate the audience, is this is a physical cable that happens and it terminates on these different gateways. I see MACsec typically enabled there, be in the colo to the cloud provider to have MACsec there. What happens if you want to have encryption brought in? We can do the encryption all the way up into the VPC with this model as well, but I'm going to instantiate Cat 8KVs up into there to get the SD-WAN tunnels further into the transit VPC, much like the similar models. So you see data center here. I had to add it. So you can do private connect with cloud to cloud, so between the different cloud providers and then the data center. And this is how we're going ahead and build out the ECMP model for that. To where now I have that same intent. That same intent is for that same prefix, the 1011/24. And I want to yield ECMP. Now I'm deriving multiple next hops, and now I can program multiple next hops. And how do we get to that? This is what it looks like. So I have that same topology, but what have I added? I've added the express route and a secondary piece of connectivity. So I have an internet gateway in this case. And now you can see on the bottom, I have the data center. The transport's sort of irrelevant. It could be MPLS, it could be internet. It doesn't really, or a combination of both. It doesn't really matter. Or it can be like a wireless private 5G connect. It doesn't really matter. To where now I can yield ECMP between the clouds, between the Azure and AWS, and also between the data center and them. So now I've yielded ECMP to get equal cost multipath routing from a topology perspective between the clouds and the data centers as well. And we can't forget the branches. The branches is the exact same thing. So we have the branch, different things, and you're feeding that into the edge, sort of talking to the cloud on-ramp for infrastructure as a service. So that's sort of the connectivity. So let's get into the security side. So where is the security perimeter? This is how I define it. It's wherever security controls are at. And if you look at what I mentioned earlier, historically, what has happened? The data center was what? The center of the universe. Everything happened. Everything went through it. Things have changed over the past several years to where the data center, like how I drew it in the topology, is no longer the center of the universe. It's more like this stub or this thing that's happening onto the side and connecting into a colo. And then the edge, you have internet and different circuits coming into there. And then the internet traffic patterns have changed significantly as well. Customers started with cloud providers with, VPNing from data centers directly to the cloud providers. Then we went to colos, and things have sort of evolved. So how do we get our arms around all the different types of connectivity, all the different types of traffic flows with users, devices, and things, and applications being everywhere is sort of what we're going to get into now. And we have 45 minutes left, and I think we may be good on time. I see people smiling. So this is what I classify things as. So I look at things, so you have applications behind a cloud security stack. So what does that look like, and what does that mean, and how do we solve for those pieces? So to start, we have to start with some use cases. So I'm taking that exact same topology that I started with, and I'm going to build upon that. So I have a whole bunch of things on the right-hand side here. I mentioned that not all applications are treated equally, meaning if I need to do bypass, we can support bypass. So I mentioned the Office 365. Typically, they say don't run that through a proxy. So we have intelligence to not run that traffic through the proxy. We can send it off directly, or however you want to handle that requirement. We have least privilege security. And then I was talking to a few gentlemen before the session. They went to Security Cloud Control, right? And I'm going to get a little bit into that. Again, I know I'm being recorded, but I just sort of tell you how it is. We have been on this journey, Cisco, of taking all of our controllers and management platforms and sort of reducing that to have a better outcome for our customers, right? I mentioned the C edges in security policy management typically was a challenge to manage at scale all the different security policies. So now that we have a tool, we've consolidated everything into a single tool, cloud delivered. We'll start with cloud. It's just easier to go to market with, and we'll come back on-prem. So now I can handle different use cases for different workloads and have different enforcement points. Why is that important? Customers need to have the choice of how to enforce, what type of device do you want to use, and where to enforce. And the reasons why I say that, depending on the use case, customers always have a non-prescriptive way of doing things. If you come to them and say, hey, you can only do it this way, it tends to fail. Meaning, I can do enforcement on a firewall, I can do enforcement on a C edge, I can do enforcement in a cloud security stack, I can do enforcement in the campus. Do you see where I'm going with this? So it could be third party. We don't want to see that, but it could be a third party NGFW firewall that integrates into the message bus that we're going to sort of close off with. Does that make sense? So it gives flexibility. Once you become prescriptive, it becomes very challenging to get something actually done. So what does this look like? So this is the site to user. So if I have a cloud security stack, and I have a remote user connecting to different types of workloads. So let's pick on the remote user going to internet or SaaS-based applications. I sort of treat them as one use case, but you can, obviously what I'm trying to depict here is you can have different security. So you can have DNS in Secure Web Gateway, which is like web proxy, as well as other things as far as APIs and things like that for the SaaS-based applications. First, delineating between SaaS and just raw internet type application. Because typically, from a SaaS perspective, you have some sort of contract or things with a SaaS provider. It's just not like a raw internet like using YouTube or something like that. It's a different business-based application. And then you have DLP controls to where you can download only, you control the classification of data, of what can or not be sent. I know I've gotten flagged for that, and I learned my lesson for that. So they sort of know what you're sending through and where it's going to, and they delete it for you automatically and send you a nice email that you violated policy. So again, for that same remote user hitting a private application, so you have the applications and the cloud service providers. You also have them in a data center up top, and you can see my ICE animation starting to animate into this. And again, choosing the different enforcement points. And then you have the middle mile piece from a private application as well. I have customers that have, so typically when customers went to colo, it was strictly for transport only. Then they added security services to this. Everything grows organically, and the use cases build upon themselves. Now customers have more rack space, more cage space. They have app hosting. They have ACI fabrics or VXLAN fabrics in there. They have a whole bunch of stuff into there. And now they're building out all these different use cases. And once you try to wrap your head, at least for me, my head starts spinning when you look at all the different destinations from all the different sources and where all this stuff is at. It's hard to get your arms around this. So I try to just lay this out because each one of these typically requires a different set of policies to have all of this happen because the destinations are in different places. And I think there's one more. So from a remote user perspective, this is pretty important. Well, the other stuff was important too. You have secure client. So it used to be called AnyConnect. You have different modules in there. So you have different ways to get the traffic from like the remote user down here up to the top. So you have per app, per tunnel, which is the ZTNA, the Zero Trust Network module as part of Secure Client. You also have traditional remote access VPN. So the reasons why this is important, I don't have to have a VPN pinned up to the head end and all my traffic just goes through there. You can do split tunnel, but now I can do per app, per tunneling in back to the different types of use cases to get the traffic out. What does the site look like? So I have a remote a branch with, I have to keep my IoT use cases happy, and then I have a user, and they want to go ahead and hit the same thing. So I'm going to start with the internet and SaaS. We have middle mile here. So depending where the SD-WAN, assuming you're using SD-WAN, it doesn't have to be SD-WAN, because it's like raw routing. Which path does it take? Does it go through here, or am I sending traffic through the cloud security stack? Right? Or is it a combination of both? Depending on how you're architected and how things are connected for that. The nice thing here, whether this is Meraki, I didn't touch upon Meraki. I just don't have the time. But we have intelligence at the edge here, like on an MX or on the C edge, to where I have intelligence at the edge, and I can make application decisions at the edge, much like I did in the remote access user for that. And then I have IoT and private applications, the same thing. I can have optimized routing, and I have controls here in the SASE stack to do least privileged security access as well. Whoops. And then back to identity and the identity firewalling. So we preserve and can leverage part of the policy. I mentioned identity. We can leverage security group tags as identity. And the VPN ID, not all customers or all environments have TrustSec deployed, right? So if you don't have a tag and you want to have a merger, if mergers and acquisitions happens a lot, or at least I spend a lot of my time on that with customers. How do you sort of do an acquisition or guest or something to where you don't have SGTs deployed? You have a VPN ID sitting at the edge, like in the branch. I can sort of pin specific traffic, whether it's camera traffic, SaaS traffic, guest traffic, whatever it is, to a specific VPN on the edge. So when it shows up at the destination, I can apply a security policy. Hey, I know this traffic's coming from this VPN. It's sort of a poor man's way of doing it statically, but it's a way to achieve the same segmentation to apply security policy in the cloud security stack. So here's sort of what looks like end-to-end. So you have the remote users, you have the sites, and the idea here is the classification and putting things on rails. And then back to I think I mentioned this earlier, but I may not have. When I do Rails, back to yes, I did. So the virtual routing and forwarding example. So if I have traffic on Rails, what happens here? Typically what happens is I have firewalls that sit in the middle that permit and deny traffic for what can talk across the different Rails in this topology. So I have end-to-end segmentation for that. What does this result in? This simplifies the security policy on the firewall. When I can start grouping these constructs in things that are like into objects. So instead of having all these IP addresses and firewall rules that are very, very long, I can now simplify that and categorize that into SGT as one example from a segmentation perspective. And then AI application. So Security Control Center I mentioned, that manages the security stack for all of these products, right? So from an AI perspective, this is a little bit early. We just started shipping about a quarter ago. But the idea here is there's two primary use cases that we're after here. One, how do I get my arms around unsanctioned AI applications in my environment? That's one. And then the moment I have sanctioned, so I have control over what can be used and what can't, that ties into the cloud security stack. Then the second part of that is, once I allow that to happen, what data can I send? You know, Cisco, like we have data classification. You have strictly confidential, Cisco confidential, public, et cetera. You can control what is sent from a data classification perspective. The second use case is from a development perspective of AI applications. Today it's supported into the cloud for like Amazon Bedrock for having hosted large language models or small language models and getting guardrails and security controls around the applications that you're deploying up into the cloud. And then on the left-hand side here, you can choose your enforcement. Again, not being prescriptive, but with the cloud security management stack, we can choose the enforcement of where those guardrails are actually implemented. So mostly distributed. Good so far? No one's sleeping, so that's good. We're on the home stretch. We're about halfway through. So here, I try to give so I look at it this way. You guys pay, and gals pay a lot of money to come. It's a privilege for me to be up here speaking to you. I try to give you as much as I humanly possibly can in a 90, whatever time they give me to do that. So thank you for bearing with me. This is saying, hey, now I have all these different pieces. How many of you are running Identity Services Engine? So about more than 3/4 of the room. The reasons why this is very, very compelling, ICE is a very widely deployed control point that we have. Mostly it started with like wireless authentication, right? So if we can take that and add more use cases to it, this is where the power of and adding more to that investment comes into play. To where I can now take these pieces, so I can take the on-premise investment of my Identity Services Engine sort of sitting here on-prem. This is my ICE icon here. Sorry, the laser's not working. And I'm vertically challenged, so the ICE is here. And the idea here is, in this model, you can see I have the VPCs defined, and I have my CIDR blocks allocated to those VPCs. In this model, I statically define the /16s to a specific group. And that's done in Identity Services Engine. In the Cat 8 KVs, I can choose to do the enforcement there, and we support both SD-WAN mode and autonomous mode. Autonomous mode is just like non-SD-WAN, if you just like regular routing, right? So I can do the enforcement. So I can have the classification happen in ICE, connected in my on-premise environment. There's my direct connect. Now I can take this metadata and exchange that up and have it mean something into the cloud environment. So I can do the enforcement in the context of this model in the Cat 8 KV. And as you can see, I have a centralized policy model here to where I have employees, the different tags and different classifications to the different things up on top that are relevant to the cloud providers. And you can see that the greens permit and the reds deny. So I can control it centrally and have it do the enforcement there. If I want to have it happen on an NGFW, virtual, right, I can take that and add an NGFW to that and have the enforcement, and the security team would own that policy as well. Or the security team typically gets involved when we're doing enforcement on routers and things like that, right, to make sure the policy is right. But the idea is I can choose where and how to enforce with Cisco and or third party up top. Make sense? So that's statically defining it. That doesn't sound like fun, does it? So now we have a way to dynamically understand what's happening. Because when you're I would even argue on-prem, it's a pain to manage IP addresses. It's a pain to manage IP, access control list policies. And this is where we're getting the group-based objects to where I can now classify all these things here. You can do SaaS as well as the cloud to where I always use the example of web servers. If I have web servers across the 3 cloud providers, including on-prem, I can classify all web servers to belong to group 10. So regardless of where web servers are at, I can run that through the identity services engine, authorization engine, derive an SGT, and now that means something to where, as a security operator, I can choose where and how to enforce that SGT across the clouds as well as on-premise. And if the IP address changes, we dynamically derive that based upon what's on the actual workload and or endpoint in those virtual private clouds. And this is what it yields. So as you can see here, the biggest change here is since we're dynamically doing this, you can see that the IP addresses are sort of, irrelevant is probably a tough term, but you're not doing a /16 CIDR block to all of this. They sort of overlap and you abstract it to where you just sort of classify it based upon the function and the role, not so much the IP address. And again, the enforcement's done on the firewall. Does that make sense? How many of you are on secure workload? It used to be called tetration. 1, awesome. Thank you. This is another way. So we have multiple ways to do things. This is another way. Tetration is a data lake. Tetration helps you with from a discovery, from a segmentation perspective. So like what's on the wire, what talks to what. It also has the ability to do enforcement. It does require an agent. The enforcement can be done with or without these SGTs. And the idea here is I can dynamically do the enforcement here, and it doesn't really, it's sort of another dynamic way that we don't really care about the IP address either. And I got a few more examples where we can do policy enforcement, up in the cloud and on-prem. The idea here is whether you're on-prem or in the cloud, we're giving you the same tooling to go ahead and accomplish that and do the enforcement. And this is another way to do segmentation into the workloads to where it understands, in the context of this, like an SGT, and it'll do the enforcement on the exact workload. And I have an example coming up here to where if the IP address changes, the policy is updated to where we just continue to do the actual enforcement. So now that we have the user and we have secure workload, just expanding upon the secure workload, I have identity services engine, and everybody heard of PX-Straight? It's a message bus. So we can have ICE integrate into secure workload to where I understand the user Tony is in group doctors and it's just an SGT of 10. The important piece here is this is where the policy becomes. So who can access patient records versus not. And the enforcement is done here into the application side of the house to where secure workload understands user Tony, group of 16, coming from the source, and the enforcement's happening for patient data because he has access to patient data here on the bottom. So what happens when his IP address changes? It updates it for you automatically in the policy engine of tetration. So I mentioned the different modules in Secure Client. Secure Client, so I mentioned like the ZTNA module, the Remote Access VPN module. There's another module called Network Visibility module. This gives you a view into what's on the client, and you can see all this in tetration. So it gives you a baseline of traffic. It can also do exceptions. So what's pretty cool is you can also see the software that's loaded on the endpoint, and you can do the MD5 hashes of like, is it actual apps that are like legit apps that are installed, or are things jailbroken, or some rogue type software on the endpoints, and we captured all of that into the data lake. It's another element of visibility for that. All right, I think I have 2 more sections and we'll be done. How many have heard of multi-cloud defense? Awesome. So this was an acquisition that we did probably about 2 years ago, a year and a half ago, to where we get cloud native security into the cloud service providers. Going back to the personas, you have the network operations, cloud ops, and I'm going to sort of focus on like the NetSecOps perspective. The only thing that's different from this and the previous stuff that I talked about, so we support all of the Data center, the middle mile stuff, OCI or Oracle Cloud is supported with this solution set. To the best of my knowledge, we don't have it with the Catalyst SD-WAN, but the multi-cloud defense is supported into the Oracle environment. It has its own policy model. You don't have to use the policy model, or if you use it, you can map it to the cloud native constructs for that. There's different gateways that are deployed. The gateways are deployed from the controller in this auto scale. So you can do reverse proxies. Where do reverse proxies typically get deployed? In front of web servers, right? So now you have a way to auto scale, whether it's a seasonal thing, a time of day thing, depending on your market, depending on your business, you can have it auto scale and the controller does that. And it also has a direct correlation to your bill. Right? So you don't want to pay for resources that you're not actually leveraging and or using. And these are all the ingress and the egress functionality that you get out of the multi-cloud defense gateways. Different deployment models. This is all automated. So we create the security VPCs for you, all of the gateways, all of the resources for you automatically to where you have, I'm going to go through centralized, you have distributed, and you can do both centralized, so combined between distributed and centralized. So what's new? This is pretty cool. So before, when we acquired, they had their own gateway. So we leveraged that, deployed that. In working with the business units in engineering, we said, hey, customers have Cisco NGFWs on-prem. They want to take those capabilities and leverage the same operational model, the same capabilities as they get with a Cisco FTD firewall. So now when you're deploying, you have the choice to deploy an FTDV firewall, which gives you the same operational models on-premise, but you also get the same capabilities. So why is this important? For this security stack, what can I do now? I know I keep picking on SGTs, but there's a method to the madness. I can now bring that into this environment as well and make policy decisions for all those services that I showed you earlier with security, like source destinations and the services, leverage and understanding what the SGT metadata is. So now I can leverage all of that, automate all of that, get the same capabilities. And I don't even know what common policy is yet, and I'm open for feedback. Sometimes the structure and the flow is a challenge, so I'm going to wrap it all up with common policy. But it's integrated in the solution set now if you choose FTD as that deployment option to come from the security cloud control pieces. So you have different ways of doing this. So the centralized model, which I'm going to touch upon, and distributed. So this is always the traffic flows. What am I trying to protect and what's happening here? To where I have a security VPC, again, automated by the controller. The traffic redirection happens automatically as well, and I created a slide for that. So between two VPCs, I have to go through the transit to get to there. So if I want to accomplish within the VPC, this is the distributed, and I need to push the gateways all the way into the VPC to control the traffic within a VPC, so intra-VPC versus inter-VPC. So centralized with the traffic flow, and then across us for that. Question? I didn't create this, but that's a pretty cool eye chart, right? So over here, these are all your workload VPCs. Over here, this is security VPC that the MCD controller spun up for you. Okay, depending on the services and the scale and everything else that you needed, all done for you, and the traffic redirection happens for you. Now, I mentioned earlier that the Catalyst SD-WAN can deploy the TGW. So remember I'm back to my brownfield comment? Who owns what? These products are integrated to where they know if Catalyst SD-WAN laid down that transit gateway, or if multi-cloud defense did, and we know who the single source of truth is for that administrative, the lifecycle management of that TGW. So if it was laid down with one or the other, we know who did it, so there's no conflict across each one of those. So this is the same topology. All I'm saying is here, let's just say I have an internet connection to align to the centralized model that we just walked through. What happens here is the multi-cloud defense, depending on your security policy that's programmed, we program the TGW to redirect the traffic where it needs to go depending on your security policy. So you don't have to do all this magic. Again, back to the stars and reducing points of administration. You can go ahead and have that be automated depending on, which applications, which traffic layers, which security services will send it to the proper point of that security VPC that I had up earlier. So this is Amazon, and I did the exact same for Azure. So I touched upon one thing, or I touched a lot about north-south traffic flows. So, user to app. What about east-west traffic flows? We can also accomplish this like API security, API gateway, so we can get into app to app in more of a east-west type traffic flow, and then east-west security policy to control different types of API security. And if you look at agentic AI, I think API security has become even more of a thing than it is today. Here we go. Common policy. So we talked about what? A lot. Branches, campuses, users, devices, things, intelligent, non-intelligent devices. You have colos, you have firewalls, you have enforcement on SD-WAN boxes, you have all this multi-cloud, you have multi-cloud defense, you have all these different things that we talked about. How do we bring all this together? How do we simplify the overall policy? This is where common policy comes in, to where we have ICE at the top. That's sort of the context, the control point, the exchange hub. So the message bus that I talked about earlier, like PX Grid, that's where that thing sort of lives here. And we build context policies within the local domains, and we share that context with the other domains. And when I say domains, it's a campus domain, a data center domain, a cloud edge domain, an SD-WAN domain, et cetera. And Meraki works with this as well, and then you can choose where and how to enforce. I modified this slide slightly because one of the biggest pieces is customers have made investments. So how do we take those investments and build upon that and bring additional use cases? And this is exactly where we're going to do that, to do context-aware policies for on-prem and cloud. And what we're also going to talk about here is the cloud security stack understands what the classifications on-prem mean to the cloud. So I can simplify and automate my security policy here. Another representation, but let's sort of get into what it looks like. So again, how many of you remember pairwise integrations? To where we had an initiative that said, hey, you have a campus environment and you have a data center environment. Pairwise means a pair, right? So you had to have a very specific set of things happening in the campus and a very specific set of things happening in the data center. It was very prescriptive, which yielded not a lot of adoption. This is what brought common policy and working with engineering. So if I want to do enforcement between the campus and data center, we're not prescriptive in what you have. You choose where and how to enforce. So in this example, I have an ACI fabric, and I have an SDA fabric or a VXLAN EVPN fabric in the campus. And now I can do the enforcement within the SDA fabric or the VXLAN EVPN fabric for that. So I have Identity Services Engine. I'm classifying the applications in the ACI fabric. I'm getting that information to ICE, and now it becomes an SGT in the regular domain. We're also very selective on what we send between the different domains because I'm convinced that I don't need to send everything in the data center to the outside world. I only need to send a subset of what the user's device or thing actually talk to like the front end of the network. So if I have 2,000 EPGs, I would argue 8 to 10 of them need to be exposed to the outside world, get the traffic in. This is a north-south solution set, right? meaning traffic coming from the campus, coming from the branch, coming from the remote user into the data center. If I want to do the enforcement in the data center, I can do that as well. So here's the firewall example. Here's the data center example. So again, this is north-south. So I'm doing the enforcement in the ACI fabric. If I want to put a firewall in between the campus and the data center, I can do that. I'm not picking on the pairwise integrations, but in the pairwise integrations, I couldn't do that before, right? It was very prescriptive. So it's topology independent, and you can choose where and how to enforce. So here I can do the enforcement here for north-south. If I want to put a firewall in the data center, and I want to control east-west traffic, can I do that? Yes. Cisco and or third party. I can insert a firewall in the data center fabric, and I can go ahead and have it peer with ICE. And again, I'm doing the policy based upon objects or groups of objects. In the last use case, the Cisco SASE Services Edge security stack, right? The cloud security stack. We have the on-premise ICE that classifies things. This is now sent up to the cloud security stack. And now as an operator, I can instantiate SGT metadata for policy into the cloud stack. Why is this important? I work with a lot of manufacturing and healthcare customers. And again, back to IoT. If I'm an auto manufacturer, I have manufacturing plants. I have things classified via ICE in those manufacturing environments. If I have a contractor coming in on a VPN, terminating in the Cisco Cloud Security Stack, and he wants to get access to an HMI, human-machine interface to do some maintenance or troubleshooting into that, I know what that classification is. I share that the Cloud Security Stack. I know that I have a contractor coming because I've classified him. So now what do I have? I have my source destination for the VPN user, the HMI interface, and it means something in the Cloud Security Stack. Very common use case. And how many of you run Meraki here? All right, so let me give a quick hit on Meraki. I know I didn't cover it. Back to the ACI example. This is the value of common policy. If I classify an app in ACI, I can take that classification and send it up via common policy to the Meraki MX. Now I can do enforcement on the MX on that, that application. Why is that important? Now you don't have to send the traffic all the way to the data center to get dropped, right? So you're doing classification and enforcement closest to the source on the SD-WAN side of the house. Same principle applies to Catalyst, but I've been picking on that pretty good, so I just wanted to throw out a Meraki example as well. This is saying the same thing. So we can do service chaining from app to app. We can do user to app with microsegmentation. Within each one of those use cases, we have the ability to apply macro and or micro segmentation to that. So hopefully what you've seen is by delivering the aspects of the network and the application over the top, we have this notion of hybrid zero trust network access. So depending on the type of device, a camera, a robot, a machine, doesn't really matter, a medical bed, a pump, et cetera, we can handle that with the firewall stuff that we talked about, as well as the application over the top to the different destinations to give you an outcome of hybrid zero trust for cloud, on-premises, and users sitting pretty much everywhere and anywhere. We have 10 minutes left, and I have one section left. So this is an iterative process. I'm going to close this out with digital resilience. And this may look like a product set of presentations. What I haven't had time to do is tie everything together visually. But if you look at what I'm about to show you with ThousandEyes and things like that, we're a little bit further ahead from a deployment and a visualization perspective. So this is a lot of the work that I've been doing, trying to bring again, a digital resilience as an outcome perspective for customers back to the problem statement of visibility. So how many of you run ThousandEyes? About half, half the quarter of the room. this is pretty cool. So you talk about internet of transport or the shadow IT problem with things running outside of your traditional four walls. So if I want to go ahead and have visibility, this is within the AWS. This is between Dallas and Ashburn, between their regions, to where I have my source to my destination. If I want to look at link latency of anything greater than 40 milliseconds, I can quickly pinpoint and try to figure out and actually see where that's at. So I can see these red links. I'm having some capacity or some sort of issue going on there. So that's within the cloud. So I can sort of visualize that. There's many more capabilities. We can do page load times and everything. I'm trying to just show from a network transport perspective. So this is going between clouds. So now I can have different vantage points that are happening between the different clouds. So if I want to look at that same example of anything greater than 40 milliseconds, I can visualize that and see specifically where it's at between which nodes and which links. So I can sort of get to root cause analysis much, much faster. A storage service. I'm just picking on a storage service. So if a user can't get access to like a S3 bucket in AWS, how do you quickly pinpoint where that problem's at? And that's exactly what this is showing, to where the circle that I have at the end on the far right, the next hop is not there. So it can't forward. So the traffic is sort of dying here. So we can go ahead and start looking at troubleshooting. It's just very quick hits to see where the gaps are and or where things are broken at. How many of you run StealthWatch or Secure Network Analytics? Again, this is a policy that work with TrustSec, and very quickly, the gray boxes between the different sources and destinations, there's no traffic. The green boxes, permitted traffic. The red boxes mean I'm denying traffic between those boxes. The eyes, if you can see the eyes, that means I'm just doing visibility, like discovery of what's actually happened between those groups. I'm not doing actual enforcement. And then I have enforcement. That's happening here. But if you see the exclamation points, what do the exclamation points mean in those boxes? That means I'm deviating from the policy. Why is that important? Because if you look here, I have a policy that's defined, but you can see I'm seeing traffic that's deviating outside of that policy. Why is that happening? So you need to sort of dig into that, but we're giving you things that are deviating from the actual security policy that was set within those zones where the eyes are at. Here's the outcome. Digital resilience is the outcome for this. So how do we get to that? So we can bring Thousand Eyes into this. This is where Cisco plus Splunk comes together to where foundational visibility is all about getting the data into the platform. So we've been working on, since the acquisition about 18 months ago, technical add-ons to where we have the networking. I would argue before the acquisitions, they were pretty bad. So now we've done a lot of investment to where we have technical add-ons for like router switches, Thousand Eyes, security, et cetera, so across the Cisco portfolio, to where we can get the data into the platform, and then in the middle bucket with guided insights, we can apply machine learning and AI to that. Why is that important? If I can give you context of where a problem is coming from, the remote user, the branch, the data center, the campus, and specific switches and devices, I now have context. So the idea here is what happens, I normalize everything, I reduce the noise, and I only give you the metrics that are really the problem, like the reds. I don't really care so much about what's green, I care about what's red, and that's where we get into the proactive response, to where you can do one of two things. One, integrate with ServiceNow, have the trouble ticketing system, as one example, be automated, but the remediation could be automated or automatic, back closer to an AI ops, self-driven type, self-driving, self-healing network. Most customers tend not to choose that option today. They still want to manually control what happens with the push of a button. That's where most customers are at, but that's sort of what we're getting at to help with proactive intelligence and predictive management and maintenance. When I say observability, it's both for the network and the application, to where we can correlate the application problem to the network problem and or vice versa. Because before the acquisition, observability from Splunk's point of view was just about the application. So we're bringing the network into that. And we also have security framework for like next-gen SOC of the future in SOAR, and then bringing XDR into this platform as well. So in closing, here's some infrastructure as code. Here's some stuff that we've done with DevNet, stuff you can sort of reuse to help with automating all of this stuff that I talked about. Go to that link for the different cloud providers, Terraform, Ansible, depending on how you're bringing in infrastructure as code into these overall environments, you have access to some of this tooling as well. So in closing, we talked about a lot. So what I tried to demonstrate here is, hey, how do I get the outcomes of users, devices, things, applications, and sort of normalize that, connect it up, segment it, secure it, choose where to enforce, how to enforce. How does common policy sort of simplify that depending on, regardless of how the user's coming in, the remote user, the branch user, and then bringing in digital resilience to tie it up from a visibility perspective. With that, if you could please complete your surveys, I would appreciate it. That's how I get better as a presenter and content creator. So feedback's welcome. 5s are the highest score. They're appreciated, but they need to be earned. So if you can complete your evaluations, I think they close tomorrow afternoon or tomorrow evening. Continue your education. And then I'd like to thank you for your time, interaction. It's been awesome to have you, so thank you.